everyone, welcome to Maths IAC. Today we are going to discuss about percentage mass in compounds. The formula for percentage mass is AR multiplied by the number of atoms of the element divided by MR of the compound multiplied by 100. AR is the relative atomic mass of the element that you are interested about. MR is the relative formula mass of the whole compound. Now, this looks a little complicated when you just say it like that, but let's take a simple example to understand what this really means. Here's an example. Find the percentage mass of oxygen in water. So, water is H2O. Now we need to find the percentage mass of oxygen. So, percentage mass is AR. AR of oxygen is 16. Now this you can look in the periodic table. The value is 16. Multiplied by number of atoms of the element. So how many oxygens are there? You got only one. So just put 1. Out of MR of the compound. So what's the total MR? Hydrogen is 1. You multiply it by 2 plus the 16. That's 2 add 16, which is 18. So all you need to do is put 18 here, multiply this one by 100. And let's put this in the calculator. You get 88.8 recurring. So let's call it 88.9%. It's a very straightforward question. In my personal experience as a teacher, I have seen that students usually overcomplicate this, but you really don't need to. So the idea is this, right? Say you have a molecule of water. You got hydrogen, oxygen, and a hydrogen. Now, the question is, what is the percentage mass of oxygen? So, what's the mass of oxygen here? The mass of oxygen is 16. How do we know? That's the atomic mass, AR. Now, if I need to find this as a percentage of the whole thing, oh, I know this is 1. This is 1. So, 16 is the mass of oxygen. Out of the full mass, the total mass is what? You just need to add them up. 1, add 16, add the other one, that's 18. So how do you convert the fraction into a percentage? Multiplied by 100, and you just get this one. That's all it does really, the formula. So the percentage mass is AR of the element that you are interested about, multiplied by the number of atoms of that particular type, divided by the MR. So you get the whole thing as a fraction. To get it into a percentage, you multiply this by 100. It's very straightforward. Let's have a look at another example. Find the percentage mass of carbon in CO2. I know carbon is 12, oxygen is 16 multiplied by 2. Now you can look into the periodic table. I kind of remember these numbers mostly because I've done it for a very long time. Just look at the periodic table and you can just get the numbers very easily. If you are unsure about how to find the MR and AR of these things or the difference between them, there's a separate video on that called Relative Atomic Mass and Relative Formula Mass. Have a look at it and that will help you to understand it. So 12 add 16 times 2 is 32. So the sum is 44. So this is my MR. So I need to find the percentage mass of carbon. Okay. So how many carbon atoms are there? Only 1. So 12 times 1 over MR is 44. Multiply this one by 100. So the answer is 27.27. Let's call it 27.3%. Now here are 2 practice questions for you. Please pause the video and give it a try. When you're ready for the answers, you can press play. First question. What is the percentage mass of sodium in sodium chloride? So sodium is 23, chlorine is 35.5, add them up to get 58.5. So percentage mass of sodium is, the mass of sodium is just 23 out of 58.5. Multiply this one by 100. So you get 39.32 to 2 decimal places. Find the percentage mass of carbon in methane. So carbon is 12, hydrogen is 1 times 4. So MR is 16. You need to find the percentage of carbon. Oh, carbon is 12 out of 16. Multiply this one by 100. So that one is 75%. Very straightforward. Here are 3 more questions. Please pause the video and do these questions. For question number 3, it's 60%. 24 over 40 multiplied by 100. Question number 4, it is 40%. MR of calcium carbonate is 100. It's a really easy one. And the last one, hydrogen is 2. because you've got 2 hydrogens, 1 times 2, 2 over 98 multiplied by 100 is 2.04%. Now, if the question does not say how many decimal places they are expecting the answer, generally in GCSEs you can go up to 2 decimal places. Let's take this a step further. Here is KMnO4, potassium permanganate. Now, I want you to pause the video and find the percentage mass of each element. So find it for potassium, manganese, and then for oxygen. When you're ready for the answer, press play. Now, potassium is 39 over Mr is 158. So multiply by 100, you get 24.68. For manganese, you put 55 over 158 multiplied by 100. And for oxygen, you got 16 times 4 is 64 over 158 times by 100. Now, there is a very interesting thing to see. If you add these three, 8, 9, 10 equals 0, 1 is carried, 6, add 1, 7, add 8 is 15, add 5 is 20, 2 remains, 4 add 4 is 8, add 2 is 10 equals 0, 1 carried, 3, 4, 5, 6, add 4, 10. So, I did it on the calculation on the board just to show you that you beautifully get 100%. So, well, that explains because you have potassium, a certain percentage, 24 something, and then you got manganese, 34 something, then you get oxygen, the remaining 40.5%. Everything should add up to 100%.